Good morning, all of you. Myself Subhanshu Ras, and I am your chemistry faculty. So today we are going to see a very important reduction, and that is birch reduction. Okay, and this is very important reduction from your JE and from your all competitive point of view, because this particular birch reduction which we are going to see today is coming into each and every examination. Like if you will see the previous year questions of JEE Mains as well as JEE Advanced, we will solve also the problems which are coming in JEE Mains and JEE Advanced. That is directly one question you will expect from the birch reduction. Okay, so without any wasting the time, let us start the birch reduction. So first of all, our today's topic is birch reduction. Birch reduction. Okay. So birch reduction is nothing, it is a basically solvated metal reduction, in which first of all, whenever we are going to study any reduction, we should know about the reagent. Reagent is very important. So in birch reduction, which reagent we are going to use, let us see. So first of all, I told that this is basically a solvated metal, okay, in which we will going to see basically the reagent which we are going to use is nothing but we are going to use lithium or sodium. Basically we are going to use alkali metal, lithium, sodium or potassium, and this particular alkali metal we are going to dissolve into the liquid ammonia. Okay, in liquid ammonia. Okay, so this is a very important reagent. Whenever birch reduction come into the mind, this particular reagent should be coming in your mind. Okay, sometimes you will found that we are also introducing lithium or sodium or potassium in ethylamine, or sometimes you will find diethylamine or alcohol as well. Okay, I will tell you why we are using this particular reagent. We are taking here alkali metal, here also we are taking alkali metal, but here I am dissolving alkali metal in liquid ammonia, but here I am dissolving alkali metal in this particular solvent. We will see why. So first of all, reagent you should keep in your mind. The second important thing about the birch reduction is that it is basically a temperature sensitive reduction. What I told, it is a temperature sensitive reduction. What does it mean, temperature sensitive reduction? Look, our condition was we need to put our alkali metal in liquid ammonia. So when the liquid ammonia will be present in, like when ammonia will be present in liquid form, when the temperature will be negative 33 degrees Celsius. So you can see, so basically for ammonia, the optimum temperature is negative 33 degrees Celsius. So you can see how less temperature is here. Okay, but this temperature is very difficult to maintain in the lab. Okay, so basically we are going to use this particular solvent, because if you will use ethylamine or diethylamine or alcohol, then you can keep the temperature between 18 to 25 degrees Celsius. Okay, so for many cases, like I am talking about these cases, if you will use this particular solvent, then you can keep the temperature between 18 degrees Celsius to 25 degrees Celsius. It means you can perform in the room temperature. Okay, and this temperature is you can maintain in the laboratory as well. Okay, so you can see how birch reduction is temperature sensitive. One more thing I want to share with you, that if you will keep the temperature between, let's say, 50 to 125 degrees Celsius, or if you will keep the temperature more than 50 degrees Celsius, then do you really think birch reduction will take place? No. Why? Because if you will keep the temperature between, or you can say that more than 50 degrees Celsius, for 50 degrees Celsius to 125 degrees Celsius, let's say, then birch reduction not take place. You will not get Birch reduction product. Why? Because at that time you are using ammonia. So your ammonia will be acting as your a powerful base. But here we are using our ammonia too, because we will see in the mechanism when carbon ion will form, then ammonia, then carbon ion will abstract the H plus. But here your if you will keep the temperature between this, your ammonia will be acting as a powerful base. So we will not get the Birch reduced product. Okay. So I am just telling about how temperature sensitive reduction is this particular Birch reduction. Okay. So I hope these two things will be very much clear to you. First about the reagent and second about the temperature sensitive reduction. Okay. The main thing is the third thing which I am going to introduce here is nothing but the solvated electron, and that is the hero of this particular Birch reduction. Let us see how. As I already told that here you have alkali metal and you are going to dissolve into the liquid ammonia. Okay. So if you will take the alkali metal like lithium, okay, and when you will dissolve in, let's say I am taking X plus Y as a stoichiometric coefficient of NH3. Okay, so if you will dissolve, if you will do this particular reaction, what will you get? There is one electron present in outermost cell of the lithium. So that will going to react with this particular ammonia and you will get Li plus, let's say here NH3 X plus you will get electron attached with NH3Y. So this particular electron is called as solvated electron, and this solvated electron is the hero of this Birch reduction. We will see how. So this is actually called as solvated electron. Okay, and this particular thing is called as lithium metal reducing product. Okay, so focus on here. We are basically going to use this solvated electron. We will see how. Look, actually when you will dissolve this particular alkali metal in liquid ammonia, this particular lithium metal will be looking like a deep blue, deep color in blue. Okay, because why? Due to this solvated electron. So here you will get a deep blue color. When you will dissolve the alkali metal in liquid ammonia, you will get deep blue color. You will get deep blue color. So this is very, very important. Maybe sometimes it can ask in examination like when alkali metal is dissolved in liquid ammonia, which color do you absorb? So deep blue color will absorb. Okay. This is the beauty of this particular Birch reduction. And one more point which I want to share with you, that whenever Birch reduction come into the mind, four things you need to keep in the mind. What are the four things? Let us see. The first thing which you need to keep in the mind is that it will reduce the conjugated die-in into 1,4 fashion, like conjugated die-in. Let us see. Let's say if you have something like that. Let's say if you have 1, 2, 3, 4. Okay, and if I am writing here Birch reduction, okay, if you do the Birch reduction, what will you get the product? You will get the product this one. It will remain same, and here double bond will come, and this will remain same. So you can see here this particular 2 double bond is going to reduce, and you will get this type of product. So basically it will, Birch reduction basically reduce the conjugated die-in into this fashion. Okay, this is the first point. The second point is very, very important point, and many times question come from this only, that it will reduce the, Birch reduction will reduce the internal alkyne, into transalkene. So always keep in the mind. We will see how. We will see the mechanism as well. The third point is that it will also reduce the alpha beta unsaturated carbonyl compound into alpha beta saturated carbonyl compound. So it will reduce the alpha beta unsaturated carbonyl compound into alpha beta saturated carbonyl compound. And the very important point, the last point which you need to keep in the mind is that it will also reduce the aromatic compound into partially. It will reduce your aromatic compound partially. This is the very important beauty of this particular Birch reduction. So it will reduce the aromatic compound. It will reduce the aromatic compound partially, not completely. This is the beauty, that it will reduce the aromatic compound partially. So let us see the mechanism one by one. First of all, this is a very important, reduce the internal alkyne into transalkene. We will see this one, the mechanism, and the question as well after that. So first of all, I hope everyone noted this. I will erase this part. Yeah. So first of all, I am talking about here the mechanism. Okay. So first of all, we will be talking about the reagent. What actually we use? Lithium plus we have that mole of ammonia, and when you will dissolve lithium into liquid ammonia, what will you get? You will get Li plus NH3X plus solvated electron. What you will get? Solvated electron. And this solvated electron is nothing your free radical. It is like your radical. Okay. So when there is a radical present in your reaction field or reaction zone, there is a high probability that your mechanism will also be following that only. I mean the free radical mechanism. Okay. So let us take the internal alkyne. Let us take the internal alkyne. So this is our internal alkyne. So let us see, when you will take this internal alkyne and when you will do the Birch reduction, what will you get the product? So as I already told that when you will take this particular Birch reduction, I mean this one, then this one is our main hero, solvated electron, this solvated electron, and I already told that this solvated electron is nothing but it will work as a radical. Okay, so here this particular bond is cleaved homolytically like this. So one electron is going to here and one electron is representing with a dot. Okay, then after this particular electron, the solvated electron, let's say, is going to attack on this particular carbon. So what will you get? You will get RC double bond, because this bond has been break. So here one dot will come, and already one dot was here, so here it will be on this particular carbon, two dot will come. It means you can say one negative charge will come, means the formation of carb anion. Okay, and this R will be there only. Okay, but do you know this particular reaction is not going too much forward? Why? Because this is very unstable and it will go backward. So the feasibility of this reaction is very less and it will go backward, not going too much forward. So what will happen? At the same point, we are using the NH3 as well. So what will happen here? Your ammonia will come, as I am using the NH3. So this particular carbon ion will going to abstract the H plus from the ammonia. So after that, what will happen here? It will form something like that, R C dot double bond C and one H is also there, and R. This negative charge is going to solve it. Resolve. Okay. So you will get this one. Okay. This is basically, this one was your radical anion. This one was your radical anion. And right now you are seeing this one. This is your vinylic radical. This is your vinylic radical. Okay. And right now this is very feasible. Right now, as you can see, the first step was reversible, but this is not. Okay. One more thing, if I will talk about the stereochemistry here, look at here. This particular one electron will be something like that here. Okay. If I will locate in stereochemistry, R, C, double bond C, here H will be also there, and here this from this carbon, your R will be this one, and this one will be your R, and here one electron will be like this. Look, your alkyl group will be in the trans position. Why? To minimize the steric repulsion, van der Waals repulsion between the two groups. If you will put these two groups upside, then there will be a steric repulsion will create, and you will get a very unstable product. Okay. So to minimize the steric repulsion, these particular two alkyl groups will be in opposite direction. Okay. And next, what will be the happen here? One electron again will come, solvated electron, and this particular solvated electron will going to fill this particular orbitals. And what will happen here? The next step will be C, double bond C. Here R will be there, here H will be there, and then carbon ion will form here again. Okay. And in the next step, what will happen? Again we have ammonia. This particular negative charge will abstract the H plus. So again ammonia will come, and that will abstract the H plus. And after abstracting the H plus, what will it form? C double bond C. Here R, here H, here R, and again here one H will come. So as you can see here, we taking here the internal alkyne, and when we are going to put the Birch reduction, it reduced into the trans alkene. So you got here trans alkene. Okay, so let us see some questions which have already been asked. How it can be asked? Like here I am telling you. Let's say you have CH3, C, triple bond C, CH3, and if they will give the Birch reduction here, or sometimes it can write here lithium in liquid ammonia, then what will be the product? Product is very simple. You just have to reduce this particular triple bond C, double bond C, and then you have to put your alkyl group into the trans position. I have already told it. Okay, and this will be your major product. Always keep in the mind, don't make the cis product, otherwise it will be wrong. One JEE advanced problem in 2021, the problem was they give you that type of structure. Triple bond, this one, this one, this one, this one, this one, this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. So this was the substrate, and they basically give you the Birch reduction. After Birch reduction, what will be the product? Okay. One thing you need to keep in the mind, I told that you have to use the internal alkyne, not the terminal alkyne. Why? Because if you will, it's better to tell you here only, so that you can solve this question. Okay, because in this question, if you will see, there is one terminal alkyne also, and there is one internal alkyne is also. Okay, but I have already told that you have to reduce the you have to reduce the internal alkyne, not the terminal alkyne. Why? So let us see here. If you will reduce, let's say I am taking here RC, triple bond C, H. This is your internal alkyne. So if you will take this particular internal alkyne, and if you do the Birch reduction, here this particular H is very acidic in nature, as it is bonded with the triple bond carbon. So this particular hydrogen is acidic hydrogen, and you are using the metal, lithium or alkali metal you are using, sodium, lithium, potassium. So what will happen here? It will form the salt. So you will get the product, first acid base reaction will take place, and you will get the product RC, double bond C minus, and then C triple bond C minus Na plus. So basically you will get this product, you will get salt. You are not getting the Birch reduced product. Okay, so always keep in the mind, whenever the terminal alkyne will be there will be not any Birch reduction take place. There will be simple acid base and it will form the salt. Whenever the internal alkyne will be there, it will reduce into the transalkene. So here it will be, what will be the product? I hope everyone will be able to give this particular answer. So this will remain same, 1 carbon, 2 carbon, 3 carbon, 4, 5, okay, 6. Here again attach with this one, 1, 2, 3, 4, 5. Started to make this one, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Okay, so started to write this one. One, two, three, four, 5 at 6 position. So 1, 2, 3, 4, 5. So it's better to use here the double bond at 6 position. Okay, and then count total 11 carbon is there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then one more will be there. So you need to reduce in that fashion. If you will represent like this one, simple, so it will be 6. So keep in the mind that your double bond should be in crossed form. Okay, so you will get this one as a major product, and this will remain same. And this question been already asked in JEE Advanced 2021. You can go and see. So directly you are getting 4 marks. See how important this topic is. Okay. Right now in the next video I will tell you how you can reduce the aromatic compound partially. Okay. So right now I am finishing this lecture here. I hope you can solve this type of question directly, and we will meet in the second video, in which I will telling about the how you will going to reduce the aromatic compound partially, and then we will also solve some important problems that can be asked in your particular competitive examination.